In this nugget, we get to chat about the concept of fault tolerance, some of the gotchas and prerequisites, and explain how it works. And in the subsequent nugget, I'll walk you through the hands-on lab to get practice in implementing and verifying fault tolerance. Isn't it a great feeling when we know we've done something really good and we're just like confident in it? And in a VMware environment, one of the things that we've implemented is a lot of fault tolerance. For example, we've got multiple network connections that go down to our various networks. For example, we have a couple for management off of each ESXi host. We've got multi-pathing with our storage with iSCSI. And of course, we also have connectivity to our vMotion and VM network. And we've also set up high availability. And in this cluster with high availability HA, if we have a host that fails, the VMs can be restarted over on another existing host in that cluster. And that's great. So I'd like you to imagine that we're talking with our management and we explain how high availability works and explain that a VM that was over here is going to be restarted over here. And what if our manager asked us, how long does that take? So based on our testing, we could actually tell them, yeah, it takes about 3 to 5 minutes for that new VM to come up on the new host. Because there's a process for detecting the failure and then restarting the VM, and it could take 3 to 5 minutes. And then as we explain that, we look at our manager's face and we see a look of disappointment regarding a critical app that needs to be up 24/7. And having 3 to 5 minutes, if we lose an ESXi host, for that VM to come back up, is what our manager is sad about. So if we're looking for a solution where we have zero downtime, the high availability solution does not deliver that. However, have no fear, I wouldn't have brought that up unless we do have a solution. And the solution for 24/7 has to be up all the time is a feature of fault tolerance, and it's at the VM level. So we could identify, for example, specific virtual machines that have to be up all the time, enable fault tolerance on them, and then if this ESXi host crashes that's running this fault tolerant machine, no problem, because in the background we have a secondary image of that virtual machine that's also running. So when we set up fault tolerance for this VM, there is a secondary VM created on a second host in the cluster, and we can use this fault tolerant feature along with DRS, Distributed Resource Scheduler, and specifically that's the vSphere DRS regarding the compute and memory resources of the host, if we have EVC enabled. That's the enhanced vMotion compatibility. That's where we specify for the cluster. For example, this is our cluster. And with EVC, we're verifying that each of the ESXi hosts, let's imagine these are both Intel-based hosts, with multiple processors and multiple cores. And with EVC, we're simply masking off or hiding certain features that are not common to all of the ESXi hosts. So if all of our ESXi hosts were exactly the same flavor of Intel, there wouldn't be a problem. However, if we have a certain version of Intel here and a little more current version of Intel over here, and the reason it's referred to as enhanced vMotion compatibility is that we won't have a VM running here using some advanced chip feature on the host that won't be available on another host. So going back to the big picture, if we want to enable fault tolerance, we have to have high availability enabled on the cluster. We can leverage DRS with fault tolerance if we have EVC enabled. So regarding the primary and the secondary VM, the actual VMDKs, they could be stored locally. For example, the primary VMDK could be stored on a local data store, and the secondary VMDK could also be stored on a local data store regarding the host that they're currently running on. However, the configuration file, VMX, and some other supporting files that are used by fault tolerance, those have to be on shared storage. And so when we set it up, it gives us the option of specifying where we want to keep them. And most of the time, we're going to use shared storage, which is accessible by all the ESXi hosts in the cluster, for both the configuration files and the hard disk files. So for fault tolerance, it's not required to use shared storage for all the files, but traditionally we're going to use shared storage for the hard drive files as well. Another aspect about fault tolerance is besides the vSphere DRS, we also have a feature that we deployed in an earlier nugget of storage DRS. And with fault tolerance, we are not going to use storage DRS with our data store clusters. Instead, we're going to use specific data stores. Now, we can use a data store that's in a data store cluster, but we can't just drop it on a data store cluster and say, figure out where you want this to go. We're going to specify the actual literal data stores. There's also some licensing requirements in place for fault tolerance. So if we want fault tolerance for machines up to 2 virtual CPUs, we can do that on Standard Edition or on Enterprise. However, The 4 virtual CPUs, that's going to require an Enterprise Plus license. One other feature that we've talked about in a previous nugget is VMCP, the VM component protection, which relates to the ESXi host being able to reach storage with the all paths down or permanent device loss as they relate to high availability. If that feature is enabled with the high availability at the cluster, then on the machines that are enabled for fault tolerance, there's going to be customization done at the VM level to disable that feature, just for the VMs involved in the fault tolerance. So regarding a few other gotchas, for machines that are set up for fault tolerance, there is no storage vMotion. Again, vMotion, the word itself implies you can't move the storage while that machine's running. And there's also no snapshot support on a virtual machine that currently is enabled with fault tolerance. And once we configure the fault tolerance, and we power on the virtual machine, the VM is going to have memory reservations for both the primary and the secondary. So if the memory on this virtual machine is 4096, at the cluster, if we look at reservations, we're going to see 4096 for the primary and also 4096 for the secondary. And with those reservations, those virtual machines are both guaranteed their full allotment of memory. Another feature in the background that we're going to be leveraging as part of our fault tolerance is vMotion. That does need to be enabled for the fault tolerance to operate. Everything that happens on the primary needs to be very quickly replicated on the secondary. And to do that, we're going to need some IP connectivity between these two ESXi hosts. And I have a question for you. What is the entity or the element inside of an ESXi host that is associated with an IP address? And it's something in the networking category. Do you recall what it is? What is the element that gets assigned an IP address inside of an ESXi host? And if you're saying, Keith, I got this, it's VM kernel adapters, you are absolutely right. So ideally, to replicate the information from the primary to the secondary VM where we're doing fault tolerance for that VM, we need to enable the feature. We need to go to a VM kernel adapter, and there's a little checkbox for FT logging. That's what it's referred to as. That's the replicating of everything that's going on the primary over to the secondary, and we need to check that box for FT logging. And ideally, we'd have a completely separate network just for that, with lots and lots of bandwidth to support all the traffic that's going to have to go back and forth between these two ESXi hosts in real time to synchronize everything that's going on between the primary and the secondary. So what we could do is go into the configuration of ESXi 2 and 3, and in the networking section, add host networking, add a new VM kernel adapter. We could put it on a new switch with an uplink that's connected to the same network as each other. And if we had 10 gig uplinks, that'd be great for plenty of bandwidth. And if we wanted some redundancy, we could do NIC teaming to that network for the FT logging function. Now, for our lab, we are out of VM NICs. I don't have any more uplinks. We have 6 uplinks in each ESXi host, and they're all being used. We've got 2 for management, we've got 2 for storage, we've got 1 for vMotion, and we've got 1 supporting the VM network. So when we implement this in our hands-on lab, instead of using a dedicated network, which would be best practice, we're just going to go ahead and double up. And let's take the VM kernel adapter that's currently associated with our connectivity to the vMotion network, and we'll simply modify the properties, enable FT logging on that as well. And that will provide the functionality and the connectivity that we're going to need in this cluster right here to support the FT logging as we enable fault tolerance on a VM inside of this cluster. So in this nugget, I wanted to chat with you about the concept of fault tolerance for a VM and take a look at some of the requirements and some of the gotchas. And then in the next nugget, what we'll do is I'll walk you through step by step on implementing fault tolerance in a vSphere environment. So I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.